Welcome to the second session of the Unit 6 of the subject that is called as Statistical Quality Control. And in the sixth unit, you'll be studying the second session of the acceptance sampling. So once again, the course outcome is the basics concepts of you are going to learn after the completion of the Unit 6. You are going to learn the basic concepts of the acceptance sampling. So in the last session, I have told you something, the introductions about the acceptance sampling, where I have told you something, I have given a little bit descriptions about the acceptance sampling. And then we have studied the applications of the acceptance sampling, where exactly we are using the acceptance sampling. And then we have studied some advantages and the limitations or the disadvantages of the acceptance sampling. And then how exactly the industry, where and all it is used. As I've told you that it is to be used right from the raw material till the end of the product. So the acceptance samplings will be used in the industry. And I have told you something about the basics in the acceptance sampling and the guidelines to be followed while going through the procedure of the acceptance sampling. And then we have studied some of the types of the acceptance sampling. So now in this class, in the session 2, so we will be studying some different aspects. So which is nothing but the most important uh, tool that we are using in the acceptance sampling, which is nothing but the operating characteristic curve. So sometimes we will call this operating characteristics curve as simply the OC curve. So this OC curve, where exactly how this OC curve is useful for us. So this OC curve, it is here in order to choose the values of capital N and the small n, as I've told you that. So uh, to sometimes, as I've told you, sometimes the lot size will be varying. Sometimes the sample size will be constant. Sometimes the sample size will be varying. Sometimes the lot size will be constant. Like that, all those things, these are the factors it will be there. We are not aware of all those things. So, we can select, if you construct an OC curve, you can select the values of capital N, that's nothing but the size of the lot, and the small n, that is nothing but the sample size. So we can choose these values with the help of the operating characteristics curves. So apart from these two things, that is called as the capital N and the small n, lot size and the sample size, as I've told you. Apart from that, sometimes there will be one of the disadvantages of the acceptance sampling is that the risk. So there will be a risk for the customer and there will be a risk for the producer. So this risk factors can also be determined with the help of the operating characteristics curve, or I can say that OC curve. So it is necessary to study the OC curve. So we to understand, to find the values of N, capital N, and the small n, and the producer's risk and the customer's risk. So it is necessary for us to study the curve. You have to study the curve, okay? So in detail here. So it is assumed that the distributions of the defectives in the lot follows the law of chances. So here, whatever the defectives that you will get, it is the defective items is only because of the chance causes. So chance causes are those causes that cannot be controlled. So it is because of that, you know. So we are supposed to study the operating characteristics curve. That's what the chance causes means. What the production process is, though the production process is totally statistically controlled. Hence, any defective unit found in the sample is only because of the chance causes only. So that's why an operating characteristics curve, when you see the operating characteristics curve, you can see here the operating characteristics curve. So this operating characteristics curve on the y-axis, if you see the curve that is indicated by an arrow, which is called as an OC curve. So this OC curve has been drawn by taking certain parameters here. That is called as probability of the acceptance, probability of the acceptance in the vertical axis, and the probability of the raw material that is incoming. So that is, with the help of these two things, we can draw an OC curve here. And we will be studying this OC curve and drawing of the OC curves in the two styles. One is by means of the tables. We can draw these OC curve by taking some factors here. And the other one is we can calculate and we can draw the OC curve here. So before studying all those things, so let us see how these curves can be drawn, how they are depend, as I've told you, they are depends upon n, capital N, and the small n. So now see here. So the OC curve is can be drawn so by means of some fixed percentage of the lot. So what do you mean by this means of some fixed percentage of the lot? Say for example, a lot is having 1,000 items. If I take 10% of that lot, so lot will be having 1,000 items. Out of 1,000, if I take 10% of that, so that is, it will be 100. Okay, 0.1% if I take, it is, 110. By means of some fixed percentage of the lot can be selected, and that can be drawn. But the percentage at which we are going to select the sample size, so it should not be, more than 20%. So, or I can say that 1 to 10% can be used, or the maximum 20% of the lots can be selected for the inspection for the to draw the OC curve. And then the OC curve will be drawn for the different values of n, and keeping the fixed percentage as follows. You can see, you can understand these things by means of the curve. So here I have shown the four types of the curve. So these curves are drawn. These are the four curves that has been drawn. So they are the OC curves. They have drawn by taking the fixed percentage of the lot. That is, small n is 10% of the lot. If you take the first curve, if you take the first curve here, so I'll show you. This is the curve which is here. So if you take the first curve here, which is at the 9th point, so here this first curve shows that this curve has been constructed by taking the lot of how much 1,000 items, and I have taken 10% of this 1,000. So the 10% of the 1,000 is what? It is 100. So then n is equal to small n, that is the sample size, is equals to 100, and the acceptance sampling is 0 here. So here the customer says that, so if this is a lot and you have taken the sample size, so that should not be any defective. So defective should be less than, equal to 0, or it should be less than 0. So this is how, so this curve 1 says, or it indicates. Now if I go to the curve 2, as you can see the arrow mark here, so the curve 2 says that there is a lot, and in that lot there are 200 items are there, and out of 200 items, if I take 10% of the 200, so it is 20. So 20 items has been selected, and with the acceptance number is 0. So it means that the consumer, he will agree for the acceptance of the lot if there is zero defective or less than zero defective. So that is the curve that has been drawn for the second second curve, where the sample or the lot size is 200. When you see the third curve, when you take the third curve here, so this third curve has been drawn, okay, where n value, that is a lot size is how much it is, 100 here. And if I take 10% of this 100, it will become 10. So now I need to take 10 items for the inspections, providing C should be equals to 0. And when I go for the fourth curve, so this is the fourth curve. So in the fourth curve, it shows that the size of the lot is 50, and 10% of this 50 is the sample size, which is equals to 5, and keeping the C is constant because the customer is 1 here. So now if you see these things, so this is the way we can draw the curve. These curves are called as the OC curves. And here, to draw this curve, we have taken some fixed percentage of the lot. Say you can see here, 10% of the lot has been selected, irrespective of the size of the lot. You can see that here the size of the lot is 50, here the size of the lot is 100, here the size of the lot is 200, and here the size of the lot is 1000. But n is what? Though it is varying, n is 5, n is 10, n is 20, n is 100, and C is constant. Though it is varying, small n is varying, but it is the fixed percentage of the lot. So that's why, so this is the one way where, we can construct by means of some fixed percentage of the lot. And this fixed percentage of the lot should be, from 1% to the 10%, or sometimes we can go for the 20%. So that is the first way of constructing, the OC curve. So there is another method. So that is called as by means of keeping the value of n constant, irrespective of the size of the lot, whatever may be the size of the lot. Here I have drawn the four curves. So if you see these four curves, I can come from the top. So here the lot size is 1000, n is 20, C is 0. He is the only one consumer will be here. So when you take the second curve, it is n is equals to 200, and capital N lots, the size of the lot is 200, and the size of the sample is 20, and the C acceptance number is 0. When you take the third curve, so the lot size is 100, the sample size is 20, and the acceptance number is 0. And you take the fourth curve, where the lot size is 50, n is equals to small n, sample size is 20, and C is equals to 0. So what does it mean? So all these four curves has been drawn irrespective of the size of the lot. See, here it is 1000, here this lot size is 200, here the lot size is 100, here the lot size is 150. But if you take the sample size, so it is remains constant. So by keeping the sample size constant, irrespective of the size of the lot, we can draw a curve that is called as the OC curve. So that's how we can construct the OC curve by means of the some fixed percentage of the lot, or we can also construct the OC curve by means of keeping the value of the sample size, that is n, irrespective of the size of the the size of the lot. So we can draw the curve in two different styles here. So the next one is we are going to study. So here, as in the previous things, I have told you the risk, that is there will be the two types of the risk that will be there. One is called as the producer's risk, and other one is called as the customer's risk. So this producer's risk, you can see at the top of the curve, some percentage will be there for the producer's risk, and there will be at the bottom, you can see there will be some percentage of the consumer's risk will be there. So, but you should know what exactly it is, the producer's risk and the customer's risk. Before that, the producer's risk will be the producer's risk will be denoted by means of the letter alpha, and consumer's risk will be denoted by means of the letter beta. So beta, alpha is for the producer's risk and beta is for the consumer's risk here. So then what exactly the producer's risk? So when a producer submits a lot having small percentage of the defective, always, it is impossible according to the Newton's second law, you can remember that. So it is impossible to construct an engine whose sole purpose is to give 100% efficiency. So whoever may be the manufacturer, whatever the things he manufactured, so there will be some defectives will be always there. So but the the amount of defective, it will vary. Sometimes, if the machines are good, so defectives will be very small. So if the machine is old, so defectives will be more. So whenever the producer produces the part, when he submits the lot for the inspection, he will be saying always that there will be small percentage of the defectives and he has the risk under the sampling plan. So as shown in the figure, if you see that the producer's risk at the top of the curve. So what is that exactly? So the producer's risk is the probability of rejecting a good batch which is having which would have been accepted. So what does it mean? Say, as I've told you, so producer's risk, say during the inspection, so at the time of the inspection, say for example, 100 items has been 100 items are there in the lot, and out of the 100, say 5 items has been selected. All the 5 items may be bad quality. When you inspect all these five, that is the sample size. So it say assume that they are bad, and who knows the remaining 95. So the remaining 95 items may be good. So that's what it is, the risk of the producers. That's what the risk is, the probability of rejecting a good batches, okay, which have been that would have been accepted. So instead of rejecting, that would have been accepted. So that risk is called as the producer's risk, and the producer's risk will be denoted by means of the letter alpha. So then what exactly is the consumer's risk? So similar to the similarly the I mean similar to the producer's risk, the customer's risk is the probability of accepting the bad batches which may have been rejected. So that is called as the the producer's risk and the consumer's risk. So in the producer's risk, sorry, in the OC curve, so here these are the 2 points that is called as the acceptable quality level and LTPD, that is called as lot tolerances percentage defective. So these are the 2 points. I'll show you these 2 points in the OC curve. So here in the OC curve, you can see my cursor. So this point, you can see this point, the line that has been drawn in dotted line, vertical line that has drawn dotted with the dots, so that line meets the horizontal line, say at the point, say 1.5. So that 1.5, it is, that 1.5 here in this graph, it is, I can say that the acceptable quality level. So it is the acceptable quality level. So then what exactly is the acceptable quality level? It will use upon the batches containing not more than a specified small properties of a defective accepted. That is, a lot that has been submitted. Always, the customer, the producers, he will say that. So there will be some percentage of the defectives in that. So small amount small amount of defectives, okay, or they can say that the properties of the defectives. So that is that should be accepted. So that small amount of the defective accepted. So the lot which is, or I can say that the lot which contains a small amount of the acceptable, I can say that a small amount of the defectives, okay. So that small amount of the defectives, we can call as the, the acceptable quality level. So this small specified portions of the defective, whatever the defective that is, who is going, that will be specified by the producer. So that small amount of the defective or specified portions of the defective is called as the acceptable quality level. So then the next point is called as the LTPD, lot tolerance percentage defective. What exactly? Say a consumer. So always he may be interested in the quality of the individual lot as well as the quality level of the supplier processes. So what does it mean? So whenever a customer he thinks, he will be thinking about the quality of the product, individual lot, whatever the lot he is going to purchase. So he is going to think about the quality of the individual lot as well as what the supplier, so what the manufacturer says about the lot. So the supplier, while giving, he may say that, so this lot may contains 1% of defective, or he may says that it may contains 2% of the defective. So he is interested in that. So the consumer, first of all, the consumer is interested in the quality of the individual items that he is going to purchase. And apart from that, he is interested what is the level of the quality that the supplier is going to give to me. So in that way he thinks. So such thinking is known as lot tolerances percentage defectives. So in such cases, he may establish a lot tolerances. So by considering both the things, that is the quality of the individual lot and the quality level of the supplier process, by considering these 2 points, so he will establish, he is going to establish a lot tolerance percentage defective. So indicating the poorest. What does it indicate? This lot tolerance percentage defective, it will indicate the poorest quality that he is going to willing to tolerate. What poor quality that he is going to tolerate. So that will be indicated by means of the lot tolerance percentage defective. So the consumer in the lot tolerances percentage defective, the consumer, he is, before purchasing any items and before the inspection, so he consider the two items, the quality of the individual lot and the quality level of the supplier. So by considering both the things, he will establish a limit. He will establish himself a limit. That limit is called as the lot tolerances percentage defective. So this lot tolerances percentage defective, it will give an idea for the consumer that what is the poorest quality that he is going to accept. Say, example, if I say that, so there is an agreement between between the customer and the producer, say, okay, and they have come to the conclusion that the lot is 100, and out of that 5 items will be selected for the inspection, and they will come to the conclusion that the consumer will say, for example, if there is a 0 defective, I'll accept the lot. If there is a 1 defective, I'll accept the lot. If there are more than 1 defective, I will not accept the lot. Sometimes what will happen here, even if there are 2 defectives, okay, if there are 2 defectives in the lot, though there is an agreement that there is a 1 defective or 2 defective, he is going to accept it. But if there are 3 defective out of that, Sometimes, if it is possible for the consumer to tolerate it, he will accept it or he is going to reject it. So if we accept that one, that if even if there are three number of the defectives, so if we accept it, then I can say that it's a lot tolerance percentage defective. So these are the two important points that will be located in the OC curve. So the first vertical line in the OC curve, dotted line, it shows the you know uh, average quality level, and the second line, dotted vertical line, that is at the point 10, it has been drawn. So that indicates LTPD. So that is about the AQL and LTPD. So AOQ, that is called as AOQ is the fraction. AOQ is called as the fraction defect defective in outgoing lots. I can say that AOQ is the fraction defective in the outgoing lot. So here, what does it means? So it means that the even say the supplier, when he takes the lot, so he takes the lot on the basis of the acceptance number. So say for example, once again I'll give the example: 100 items in the lot is there, and 5 items have been selected. Say C is equals to, it is an agreement between the customer and the producer, thinking that C is equals to 2, up to 2, 0. If there is a 0 defective in the lot, he is going to accept it. And if there is a 1 defective in the lot, he is going to accept it. If there is a 2 defective also, he is going to accept it. So, but 3, if there are 3 defective, he is going to reject the lot. So so even though there is a 0 defect, he will take 1 defect, he will take 2 defect, he will take. But if there are 3 defect out of 5 items, so he is going to reject that one. So what does it mean? It means that whatever this lot he is going to accept, that will be having that accepted lot, that is called as the outgoing lot, that will be always having some fraction defectives. So that is what it is called as AOQ. In many cases, the rejected lots are 100% inspected. Sometimes if the lot is, there is, because there is a producer's risk will be there. That's why, the rejected lots will be 100% inspected, and the defectives are replaced by the good ones. So due to this, proportions of defective remaining taken over all the batches, leaving inspection will be less than the overall proportions arriving at inspections. So average outgoing quality, that's what an average outgoing quality is called as the fraction defective in the outgoing lots. So an average outgoing quality is overall portions of defectives in a large number of batches leaving the inspection. When the lot leaves the inspection, it will be having some proportions of the defective. So a large number of the batches leaving the inspection and all the batches having the same proportion P defective on the arrival at the inspection. So, or in other words, I can say that AOQ is the fraction defectives in outgoing lots. So then, so this AOQ is, you can see, we can represent in the OC curve, we can represent this one. AOQ is AOQ if there is no inspection. So AOQ, if there is no inspection, it will be a straight line. AOQL is maximum when the curve, the maximum point on the curve. So you can see a curve here, sampling plan. So you can see a curve here. So the maximum point on that is called as AOQL. And when there is no inspection, this line will be a straight line. So AOQ sampling plan will be, you can see it here in this graph. So next point, AOQL. So what is the AOQL? So average outgoing quality level. So average outgoing quality level. So that is, if batches arriving at the inspection contain small proportions of the defective P, say we always, as I've told you that whenever the consumer, whenever the consumer takes the lots, always there will be some percentage of small amount of the defectives will be there in that. So only very few of them, will yield bad samples, and and have to be inspected. 100% inspection should be done. So the AOQL will be only marginally less than the P dash when P is sometimes large. So it means that, so AOQL, it will be the average outgoing quality level. So after the inspections, so it will be a very small amount, and this small amount, will be tolerated by the consumer. So the small amount, can be, inspected. We have to do the bad products has to be inspected. That is called as the 100% inspection has to be done. So that is called as, this is called as AOQ, and that you can see that AOQ is the maximum, when this AOQ is maximum, it is average outgoing quality. So at the midpoint, or the highest point on the curve, is called as AOQL, and that will be maximum for when you go for the inspection. See this line, is a line, it's a curve, is a line. So when there is no inspection, when there is an inspection, it will be a curve. And here AOQ, that is average outgoing quality, will be same as average outgoing quality level. So the just difference is that here is a level, it is the average outgoing quality, and it is the average outgoing quality level. So it means that when there is an inspection, so this point is called as the AOQ, and this AOQ is maximum. Over this we cannot go for that. So this is a maximum, and that maximum will be equals to average outgoing quality level. So that is about the average outgoing quality level. So here I have completed the session 2. So thank you very much.